So good morning, everyone, or good afternoon, depending on where you are. Thank you for taking the time today to attend our webinar, The 3 Pillars of Effective DevOps Test Automation. First, a little housekeeping. We'll be sending out a link via email to both the slides and the recording to everyone that attended and or registered. And also, please, if there's any questions as we go through, enter the questions in the chat. We've got a lot of content to get through in about 30 minutes, so if we don't get to your question live today, we'll definitely respond via email within 24 hours. So let's get started. So a little bit about me real quick. I'm CTO of Utopia Solutions, QA and testing focused service provider. Personally, I've been involved in QA and testing for over 25 years now, with most of that time focused on implementing test automation. My thoughts on automation have certainly evolved over that time, and I've developed a passion about helping folks implement automation the right way. If I have any questions after the webinar or just want to talk about any of this stuff, please feel free to contact me through any of those means there shown on the slide. All right, briefly, the agenda for today is going to include a short intro on the importance of testing and test automation in DevOps, and then we'll spend the rest of the time focusing on the 3 pillars of effective test automation, which I believe are scope, approach, and then test environment and management. And then we'll have a quick wrap up and hopefully time for a few questions live at the end. So, the goal behind the DevOps movement is to reduce development cycles and more frequently release high-quality software that hopefully is closely aligned with business objectives. And in DevOps, testing moves from being part of the development cycle to being throughout the cycle, right? But for DevOps to really achieve its potential, the feedback that we get from our testing activities needs to be fast, accurate, and actionable. Right? We can't be waiting for long, slow tests to run and then sift through piles of results to try to understand if the build is ready to be promoted. And we certainly can't be wasting our time chasing down false positives or negatives. So if testing is important, we also need to understand the importance of test automation in DevOps. And I think a good way to do that is to look at this description of required continuous integration capabilities from the DevOps handbook. Which I will highly recommend, by the way, for anyone looking to get really a practical guide to DevOps practices. I've highlighted the important parts with respect to automation. And the first point says that we should have a comprehensive and reliable set of automated tests. And the next point goes on to say that we need to have a culture that stops the pipeline when those tests fail. So if we're going to pull the emergency brake when our automated tests fail, they better be reliable, right? We're not going to get too many chances to prove reliability if we keep crying wolf. So another way to look at the importance of test automation is to look at the level of automation across different categories of DevOps performers. And this is some data from DORA's 2018 State of the DevOps report. That shows the level of manual work across different categories of DevOps activities. As you can see, the high and elite performers have quite a bit of test automation compared to medium and low performers. And that's true not just for testing, but other DevOps activities as well. So if we can agree that we can't be successful with DevOps without effective test automation, it's important for us to be aware of some common obstacles or traps, as I like to call them, to having effective test automation. First is either too much or not enough automation. I see a lot of instances where there are a ton of automated tests that were created in some cases just because they could be automated. And that really isn't enough justification if we're going to be adding them to a DevOps pipeline. And a lot of times I see organizations that are certainly very proud to say that they run maybe thousands of tests every day. But really, when you dig in a little bit, there's not a whole lot of knowledge about what those tests are doing in terms of understanding the business risk of the build. So this is definitely not a quantity over quality type situation. I also see instances where there's not enough automation. Maybe there's very little coverage for whatever reason. and there's just not enough to make an impact on your efficiency. Certainly automating the wrong tests, right? Tests that aren't providing value and tests maybe that can't be reliably automated will turn out to be a waste of time. And we'll spend some time talking today about how we can identify what those right tests are. Next, and this is a huge one, focusing on UI tests. Why? Because I think a lot of us got our start in automation doing UI level testing, and we're comfortable with that. But these tests are the slowest, most unreliable type of automation there is. I'm not saying we shouldn't have any. Certainly there is value in validating that the UI is doing what it's supposed to be doing. But I'm saying if 100% of your tests across your pipeline are at the UI level, that's going to be a problem. And this is also one of the top offenders that we'll spend a lot of time talking about, and that's not having stable test environments or data to execute on. And finally, not treating automation as code. And we're not going to talk about that too much today, but I think it's suffice it to say that if we're going to rely on our automated tests, at least in part, to assess the quality of our product, we need to treat the code that those tests are built on with the same care that we give the app that we're testing. So we talked about the obstacles of test automation success. Let's see what effective automation looks like. Right? And again, I found that the three main pillars or attributes of effective automation are scope, approach, or the method used to implement automation, and environment and data. Scope and approach go hand in hand, so I'm going to talk about them together a little bit on the next few slides. So before we get into a detailed conversation about test automation scope, let's look at some trade-offs we encounter in a DevOps delivery pipeline. As we go further down the pipeline, we have an increased confidence in a build's readiness for deployment to production, and typically the environments become more production-like. The trade-off is that as the test environments become more complex, the time it takes for those tests to give us feedback increases as well. So as we'll see, we're in this constant battle between risk assessment and coverage, and then against the desire to get fast feedback and move through the pipeline quickly. And as we'll see, this really highlights the need to think critically about the types of test suites we create, and then within those test suites, which specific tests we're adding to them. So let's start with determining what test suites we need as part of our delivery pipeline in the first place. A good way to do that is to use a process introduced by Katrina Clokey and further refined by Ashley Hunsberger, and that's the test suite canvas. The idea behind the test suite canvas is to think about important aspects of each of the test suites that we're thinking of creating, so we can first of all determine if we need it, and then figure out what it's going to do and how we're going to implement it if we do. And this should really be a group exercise, right? So get the entire team involved, not just the automation engineer. And it does a great job of getting everyone thinking about the details associated with each test suite. It's sometimes easy to say we're going to have an API integration test or an end-to-end test suite and not really think about the details of how that'll be created, how it might fit into our pipeline, and ultimately who's going to be responsible for it. So let's go through quickly each part of the pipeline here. First is the purpose, and I like to state that in terms of the business risk that the test suite's going to mitigate. We're going to have dependencies. So what systems and tools do we have to have in place for this test suite to exist? And we're going to have constraints, right? There's going to be things that prevent us from implementing this test suite in the way that we want it to. And we need to understand what those are up front to see if we can overcome them. From a pipeline and execution perspective, we need to understand where the test suite will exist as part of the pipeline. When will it be triggered? How often will it run? Environment and data, as we'll talk about, is very important. What test environment will this test suite execute in, and how will the data within that environment be managed? From an ownership perspective, we need to know who's going to own it, who's going to create the test suite, who's going to address test failures, and how are they going to do that. Maintainability is important. What will the process be to review code? Let's say we have to hand off the test suite at some point, what documentation at a minimum needs to exist to make that less painful. And finally, and this is very important, how will we know the test suite is giving us the value that we expected out of it? How do we know that it's mitigating the risks? What are we going to monitor to understand that? And we'll often then take each canvas for the different test suites that we're thinking about and put them into a single spreadsheet, one row per test suite, so we can more easily see the universe of testing that we've mapped out across our pipeline. And this exercise really helps you visualize how the test suites will be run, in series and parallel, if that even matters. And once you have that universe of test suites created, it's a good idea to map those test suites to your pipeline, so you can visualize the flow of the build with respect to how you're assessing its risk as it moves through the pipeline. So it's one thing to understand what test suites we need, but now let's look at how we can evaluate if a test is worthy of being part of a test suite. If your automated tests are going to be part of a DevOps pipeline, then they need to be run really anytime on demand. And as we already discussed, they need to provide fast, accurate, and meaningful feedback. Boz Dijkstra has come up with a great acronym for reminding us how or about the qualities to look for when determining if your automated tests are fit for continuous testing or testing as part of a DevOps pipeline. And that's FITR. It stands for focused, informative, trustworthy, and repeatable. So first, focused, and this really refers to testing the functionality as close as possibly you can to where it's implemented. For example, let's say the purpose of your test is to test a tax calculation that's performed by an API. And let's also say that for some reason, for the sake of argument, that you create a test that attempts to do that by checking the value in an invoice total field on the UI. And now you find an issue. The total invoice value isn't what you expect it to be. Certainly could be because the API has an issue, or it could be one of a dozen other things. And now you've set yourself up for a long investigation because you're not testing that API as close as you possibly can with a with a direct API test. Next is informative. First, if your tests are focused, I think that will help them to be much more informative, but you can do more. For the test itself, it should be as self-documented as possible. Someone looking at the code should understand its intent. Similarly, the output, so the login and the reporting, should provide feedback as to what happened if an issue is encountered. For example, if a test encounters an issue because it couldn't locate a UI object, I don't want to see a stack trace. I want to know what field it was trying to find. I want to know what locator was being used to find it, and probably a screenshot. And 99% of the time, if I have that information, I'm going to be able to quickly understand what went wrong. Next is trustworthy, and this is certainly a big one. If we're going to be part of the build pipeline and part of your culture is to stop that process if an issue is encountered, your tests have to be trusted. If they can't be trusted, they're going to lose the privilege of being part of that pipeline, or they'll just be ignored, and neither situation is ideal, certainly. Finally, repeatable. If your tests are going to be kicked off automatically by some event that you're not controlling, they better be ready to go. And this usually means that you've taken care of business with respect to test environment and data management. And again, we'll talk about that in a bit more detail soon. So let's move on to environment and data. One of the most common phrases we hear when trying to understand and reproduce an issue, especially if we're having difficulty, is that it worked on my machine. And as we just discussed, the test automation scope and approach are certainly obstacles to effective automation, but as this year's World Quality Report said, test environment and data are the top challenges, and this has certainly been true for quite a while. You can do a great job of figuring out what test suites you need and which tests should be in those test suites, and then build the very efficient, very effective frameworks to execute them. But if you don't have stable test environments and data, it's not going to matter. One what we want to do is try to understand how we can eliminate the well, it worked on my machine from our vocabulary, at least with respect to automation. So with respect to environments, let's take a look at the spectrum of test environments and data situations. At one end, we have the good old static shared environments that are created and seem to persist forever. And I still see a lot of people implementing DevOps processes that are working with those types of environments. And I've added stale to that because I think by their very nature, the data in these environments often becomes stale over time. So, but these types of environments will often cause a set of cascading issues. Because they're shared, that causes instability in the data, right? Someone changes the data that is needed by someone else. And depending on the approach to managing that data, and often there isn't one, the data is probably stale. We also have scheduling conflicts, right? We have UAT trying to do their work, but someone also needs to run a load test, and maybe training wants to use it because their environment is even worse shape. And it's probably not very production-like, right? Very often not in size or shape, but also often no one is quite ever sure of what the configuration of the environment is at any given time. And those issues are the root cause of many of the automation challenges we referred to earlier. Right? Data instability is going to result in unreliable execution. Because we can't rely on the data, we may be forced to set up all our data each time we want to execute, and that can result in situations where our feedback just isn't very fast. Data or configuration issues can result in false positives or worse, false negatives. And all that really points to a ridiculously long time for analysis, because you can never really be sure if issues are actually issues. And then if they are, you've got a long analysis to figure out what caused them. So let's take a look at the other end of the spectrum for a second, where we have dynamic, dedicated, fresh environments. If they're dynamic, that means we can create them on demand using virtualization and infrastructure as code technologies. Because they're easier to create and manage, we can likely have more of them and dedicate them to a specific purpose or function, and then eliminate all the issues associated with sharing environments. For the same reason, we can make them production-like if we want, or at least be in a state where everyone is working in separate but identical environments, and that will go a long way to eliminating the "it worked on my machine" excuse. And since we're creating the environment on demand, we might as well ensure that it has the data we need in the state that we need it to be in. So let's move on specifically to data. I'm sure we can all relate stories of testing issues we've encountered that were somehow related back to data. And if we look at the last year's World Quality Report, the biggest challenges that were identified to effective automation were, first of all, keeping data in sync with the tests. And this is a situation where tests are inputting some data that is no longer appropriate given the current state of your system, or the test is expecting a data response that is different from what the system is giving. Next is a lack of test data for complex integration testing, right? These are typically tests that are further down the pipeline, could be something like a long order management flow. Finally, and I think similar to the second point, is maintaining consistent data across systems under test. And to me, this speaks more to data in external services or other systems that make up an end-to-end business flow. But independent of the specific challenge, it all results in the inability to reliably execute automated tests on demand. And that really flies directly in the face of what DevOps needs from test automation. So what we're pointing to now is a need for a test data management strategy. If you remember back to the Test Suite Canvas, one of the sections we talked about was data. And this is something we need to think about before we start building frameworks and tests, and certainly something that has to be done before we need to execute them. So as we think about our test suites and subsequently the tests that we're going to add to them, we need to pay attention to the data that each of our potential tests may need. It's very easy to just begin creating tests and almost subconsciously include the data. However, we have to understand what I call the dimensions of that data. And these are essentially the attributes of the data that describe how it lives and behaves in your system. First is the type of data, and in most cases this means if it's structured, for example, data in a relational database, or unstructured, where there's maybe no fixed format, length, organizational pattern, etc. Of course, the value of the data is important, either a specific value or a specific class of values that are important for the test. Time is also an extremely important dimension. A lot of times when we have tests that pass for a period of time and suddenly start failing, time turns out to be the culprit. Maybe the data has expired, for example, an insurance policy related to its or insurance policy that has reached its expiration date. The ability for data to be reused or not is important, right? So if for example, I'm testing an e-commerce system, the account I'm using to purchase items can likely be reused. However, if I'm testing shipping an order, I can probably only ship that specific order once. Volume of data is also important, and this almost certainly comes into play for load testing, where you might need a number of user accounts to spread across your concurrent users. But there's also some subtleties here. Sometimes you need a specific data value to have that represents volume to have a specific value. Think about some level of inventory or maybe some level of available credit associated with an account. And finally, where does your data live, right? What are the sources? If you're going to possibly develop a strategy to manage the data, you need to understand where it's coming from so you can evaluate your options for controlling it. So let's now think about some strategies that we can use to manage that data. And there's no step-by-step recipe for developing a test data management strategy. It's going to vary quite a bit, actually, from organization to organization, right, based on where the data lives, what the dimensions are, the state of the test environments, even what works for an e-commerce system in one group may not be appropriate for the exact same type of system in another group. I think it's better to talk about potential techniques we can use, right? So we can expand our tool belt, and then we have a larger set of tools and approaches to use when we start to dig into our own situations. First, there's some things you can do at the application level. We've got the kind of tried and true data refresh. We're essentially replacing the current data in your environment with data from a known state, very often production, which may or may not be known. And this is a fairly common approach, but the way it's typically done doesn't work very well in DevOps. Typically, the refresh is done on some cadence that is probably way too slow for your DevOps pipeline, right? Remember, we want to be able to execute on demand. Also, this might not work very well for integrated systems that can't be easily refreshed at the same time. Next, we have data partitioning. This is where we dedicate certain data objects for use only by the automated test suites, maybe certain accounts, certain warehouses, etc., that are only used by a specific test suite. And this helps with issues that are related to shared test environments. Of course, that assumes that other users respect the fact that that data is dedicated. We can also dedicate entire environments to test automation. And of course, the feasibility of this depends on a number of factors like complexity and cost. And these can be effective, but may not be flexible and nimble enough alone for DevOps. So there's some things you can do at the test suite level that lend themselves a bit better maybe to a DevOps environment. First, we can have our tests create the data that they need prior to execution. This is often combined with data partitioning to maybe further lessen the chance of data-related issues. For example, a test might create some inventory that it needs, but the SKU and the inventory location are designated for automation only. Similarly, we can have the tests clean up after themselves. This is typically done in conjunction with pre-test data creation. And this next one is similar to having dedicated automation environments, but with the added twist that we're creating test environments in the state we need it, when we need it, and then if necessary, we can blow it away. Finally, we can build capabilities in our frameworks that handle data that changes over time, because again, time is an important dimension, or maybe data that follows some rules that make it impossible to use the same data for each execution. And of course, we have full-blown test management solutions. that were purpose-built for managing data in test environments. I like to throw service virtualization in here as well, where service virtualization can address situations where you need to test your code against dependencies that aren't yet ready. It also comes in handy for addressing data issues in dependent systems or components that are outside of your control. Important takeaway here is understand that first, test data management is important to test automation, and secondly, we have a decent tool belt of techniques that we can use to address it. It's extremely important to understand your application, its data dimensions, and of course the environments you're working with before you can begin to discern what an appropriate test data management strategy is for you. So before we get to questions, I want to talk a little bit about some key takeaways. So as I mentioned, DevOps is a culture, right? It's not just a set of tools and processes. And the same applies to automation. If you're going to get that fast feedback and move the build through the pipeline efficiently while still effectively assessing its risk, test automation is absolutely required. To do that, you really need to understand what test suites are appropriate, and not just a name only, but really dig into them using something like a test suite canvas to understand why you need them in the first place, and then how they're going to be created, maintained, and managed. Once you've done that, again, extremely important to make sure that you're getting the right tests in that test suite, right? We have that constant battle between assessing risk and managing risk against the speed of the feedback that those tests are providing. So we really need to ask ourselves, if we add a test, do we really need the information supplied by this test? Or conversely, are we okay with not having the information supplied by this test every build? And finally, right, all of the above really doesn't matter if you don't have stable test environments and test data. So you really need to understand your test environments and data dimensions and have created a strategy to manage them. So I think we have time for a couple live questions that have been fed to me here. Again, if we don't get to your questions, if you've already submitted them in the question chat or anything that comes in after the fact, we'll get back to you via email. And typically, we can do that in about 24 hours. So again, if it's not answered now, expect an answer here in a day or so. So first question, and this is a good one. You didn't mention much about frameworks. How important is the architecture and design of a framework in effective test automation, especially in a DevOps environment? So again, great question. And the topic today was more about, right, the foundational components of automation, the processes you need to think about so that when you do implement a framework, it can be effective. Obviously, the architecture of the framework is important. And my philosophy is it should be as concise and maintainable as possible. I think that's a pretty common philosophy. We like to use a layered approach where the core functionality such as logging, reporting, accessing external data, general UI interaction, general API interaction, etc., forms the foundation. Those are the things that all your frameworks are going to need. Then the application specific layer is built on top of that. So that might be your page objects for a UI level suite, or specific API flows for more of an integration level suite. And finally, the test layer should sit on top of that and then use, interact consistently with those core layers of the framework. I will also say that we also like to handle both UI and API automation in the same framework. And really, the reason for us is that it just allows us to have a single core code base to manage versus having complete independent frameworks for each of our test suites. Okay, I think we have time for one more question. You talked about how important effective test automation is for DevOps, but isn't there more to DevOps than that? And I'm really glad someone asked this because yes, DevOps is much more than test automation or any tool or process for that matter. It's really a culture, and to be successful, you need to do the hard work to change that underlying culture. And again, I think the DevOps handbook, which was meant to be a kind of a practical guide to the Phoenix project, which is really a fictional novel about how an IT organization was transformed. I think those are both great kind of foundational sources to understand DevOps in general. But the same thing applies to automation, right? Which is more of what we talked about today. We're not going to be successful with automation if you think of it as just a tool or just some independent process. It really has to be part of the way you develop and test software at a cultural level. So thank you for that question. So we're going to wrap up now. Again, thank you to everyone for attending and for your time today. We'll get back to any other questions that weren't answered live via email, as I said, and then you will get an email as well with a link to both the slides and the recording. If any questions come to mind, or again, you just want to talk about this stuff, feel free to get a hold of me at any of those methods shown there on the slide. And I also blog relatively frequently there on our blog, so feel free to check that out. Again, thank you everyone, and I look forward to seeing you next time on our next webinar. Thank you.